Download this code from codegive.com, link in the description below. Clean architecture is a design philosophy that emphasizes separation of concerns, testability, and maintainability. In this architecture, validation is an important aspect that should be carefully placed to ensure that the application remains clean and adheres to its principles. The placement of validation code can vary based on the type of validation being performed: input validation, business rule validation, or domain validation. Overview of layers in clean architecture. 1. Entities, the core business logic and rules. 2. Use cases/interactors, application-specific business rules that orchestrate the flow of data and handle application logic. 3. Interface adapters, convert data between the format used by the use cases and the format used by the outer layers, like UI, database, etc. 4. Frameworks and drivers, the outermost layer, which includes UI, databases, frameworks, and external services. Types of validation. 1. Input validation, validating user input before it reaches the business logic. 2. Business rule validation, ensuring that the business rules are adhered to within the use cases. 3. Domain validation, validating the state of domain entities. Where to place validation code. 1. Input validation. Input validation should be handled in the interface adapters layer. This is where data is received from the user or external systems. By validating input here, you can prevent invalid data from reaching your use cases. Python. Interface adapter layer. Class user input validator. @static method. Def validate, user_input. If not user_input.get, username, or len, user_input username. 3. Raise value error, username must be at least 3 characters long. If not in user_input.get, email. Raise value error, invalid email address. Return true. 2. Business rule validation. Business rule validation should be done within the use cases layer. This ensures that the application logic adheres to the defined rules regardless of how the data was received. Python. Use case layer. Class register user use case. Def__init__, self, user_repository. Self.user_repository equals user_repository. Def execute, self, user_input. Here we assume user_input has already been validated. If self.user_repository.username_ exists, user_input username. Raise value error, username already exists. Proceed with registration logic. User equals user, username equals user_input username, email equals user_input email. Self.user_repository.save, user. 3. Domain validation. Domain validation is part of the entities layer. It ensures that the domain model remains in a valid state. This validation is typically done in the constructor or setter methods of an entity. Python. Entities layer. Class user. Def__init__, self, username, email. Self.set_username, username. Self.set_email, email. Def set_username, self, username. If len, username, 3. Raise value error, username must be at least 3 characters long. Self.username equals username. Def set_email, self, email. If not in email. Raise value error, invalid email address. Self.email equals email. Summary. Input validation, should be placed in the interface adapters layer. This prevents invalid data from reaching the application logic. Business rule validation should be placed in the use cases layer, ensuring that the application correctly enforces business rules. Domain validation should be placed in the entities layer, maintaining the integrity of the domain model. Conclusion: by carefully placing your validation code in clean architecture, you can create a robust, maintainable, and testable application that adheres to the principles of separation of concerns. Each layer has its own responsibilities, and proper validation ensures that your application behaves as expected while remaining flexible for future changes.